Okay, so this is our final tutorial, our final video tutorial for exercise 1, problem 3. And if you haven't if you haven't gone through videos 1 and 2, you might want to do that because in order to make the video a little bit shorter, I'm not going to go into some things that I covered in videos 1 and 2. Okay, so number 3 asks us to write a short code in Fortran to compute this summation. This summation is over the variable I, and the initial value for I is 1, and it goes all the way up to n, whatever n equals, and then it's divided by n. Okay, so this is an average, essentially, of a sum that goes 1 plus 2 plus 3 plus 4 ... n minus 1 plus n. Okay, so if n equals 2, for example, this is the sum of 1 plus 2, which is 3, divided by n, which in this case is 2, which is going to be 1/2. But we're going to generalize it so that it'll work for any value of n. Okay, so I'm going to pull up my text editor here. Okay, and in my text editor, all I've changed is the name, is this line of the file to say exercise 1 problem 3, and I've saved it as x1_3.f. Save it here, and then I have my terminal here. Okay, so this is problem 3. Write a short code to compute this sum. So just as we did before, we want to define our variables before we use them. It's just a good practice to do. It's just good practice. Averages are typically not going to fall on integers. If you compute your GPA, or if you compute the average weight of a football of linebackers, it's not going to be a nice round integer. It's typically going to be a real number, so our fraction or decimal number. So we're going to use real to represent our average, and we're going to also do that to represent our sum. Our sum is going to be our average is going to be our sum, of course, divided by the number of numbers we add together. So, okay. And so the number of numbers that we're going to add together is n, so that's going to be an integer. That's not going to be a decimal or fraction number. And we can go ahead and let I also be an integer. Okay? And actually in Fortran, just as to make things convenient for people that program in Fortran all the time, you don't actually have to define I as an integer. There's a certain range of variables like I, j, k, l, m, n that are, if you use them without defining them, they're going to be automatically by default integers, and the reals are going to be they're also in a certain range of the alphabet. But just to start you off, if you're just starting out, it's good to just go ahead and define your variables, and then you can use the convenient features they have for different Fortran compilers later on, after you get used to the idea of defining variables and what it means to define a variable and so forth. But so I'm defining the variables here. Got 2 integers and 2 real numbers. And when we're computing an average or a number, or calculating a number in Fortran, we first want to make sure that, especially with a sum, we want to make sure that the initial value of that sum is 0. Because if it's not defined, sometimes there'll be just a random number there. And you start using it, and it might not start off at 0, it might start, and so you just want to make sure that you define it initially at 0. Okay, and we also want to specify what n equals. We want to specify that n is some finite value. We'll just say 10. Okay, and the whole purpose of this exercise or this problem is to demonstrate a finite loop. And in this particular finite loop, there are a number of different finite loops you can do using Fortran and illustrate the do loop. Okay, so we're going to have do, and the syntax for the do loop is as follows. You're going to say do I, I'm going to do, and then the loop variable, and then specify your loop variable, which is in this case I here. And going to type equals and then specify the range that you're going to go over. So in this case, we're going to go from I equals 1 to I equals n. So that's 1, comma, n. So in this case, it's going to go from 1 to 10. And then we end the loop with end do. Now, whatever we put in between the do and the end do is going to be executed n times. So in this case, since n equals 10, it's going to be 10. If you change this to 12, it's going to be executed 12 times. Okay, and so you get the picture. It's going to be executed 10 times, n times. Okay, and what we want to do every single time, what do you think we want to do? We want to add to this sum of 0 whatever the value of I is. So the first time we want it to add 1. The second time we want to add 2. So 2 plus 1 equals 3. To that sum, we want to add 3. So 3 plus 3 equals 6. To that sum, we want to add a 4. So 6 plus 4 equals 10, and so forth. So the way we do that is to go ahead and specify what the sum is. Sum is going to be equal to 0, and then we're going to add I to it. Okay? And then we're going to have to put that into a variable. Okay? The way we're going to do that is to just simply re-specify or reassign sum. Okay? We're going to give sum a new value. So we're going to say the new value of sum equals the old value of sum. Whatever is on the right side of the equal sign is going to be the old value of what? Of what's on the left side of the sign. So this is the old value of sum plus the integer of I, which is going to change every time depending on where we are in the loop. So the first time I is going to equal 1, sum is going to equal 0. 0 plus 1 equals 1. So the new value of sum is going to be equal 1, and it's going to go to end do. It's going to evaluate I. I is going to be 1, which is not n, which is not 10, so it's going to repeat. So it's going to increment I and repeat. So I is going to be equal to 2. Sum is going to equal to 1 here. Sum is going to be 2 is going to be added. The new value of I is going to be added to the sum. It's going to increment to 3. So the new value of sum is going to equal to 3. It's going to execute the end do. The end do is going to say I is not yet 10, so I've got to keep going. I'm not done yet. It's going to increment I to 2, or increment I to 3, and start over at the beginning. Sum is going to equal 1 plus 2, which is 3. I is going to equal to 3. And so this new value of sum is going to equal 6, and it's going to repeat over and over again. All right? All the way until I equals 10. Okay? And then what we want to do is print out that value. We want to store that sum. What an average is a sum of all the numbers that have been added divided by the number of numbers. So to express that in Fortran, that's going to be average equals sum divided by n. So now sum is the total number 1 plus 2 plus 3 plus 4 all the way to 10 divided by n. And we're going to set average equal to that. Okay, and then we're going to display our average. Okay. All right. So let's see what that looks like. Let's save saving our text editor. Let's come up to our directory. Let me get back to our directory class. Okay, we've got a.out. No, we haven't. We have to compile it. So G Fortran. Okay, and we're going to what source code are we going to compile? We're going to compile ex1_3.f. Okay, and it looks like we don't have any problems. Let's do our directory listing. Yeah, this is a.out. It's new. It's been recently compiled, so this is our new code. So let's go ahead and execute it with ./a.out 5.5. And if you add that up by hand, you'll see that that's the correct number. But let's look into this a little bit deeper. Let's make this a little bit more clear. Let's show what sum is after every iteration. Okay. So so before sum is being we want to show the very first value of sum and all the values from there on out. So let's print star comma. I'm going to say this is I equals this. When I equals this, okay, the string, comma, I, give it a space, and then space sum equals, and then I'm going to place this give the variable the sum. So we have a string that's going to be printed explicitly. I equals, that's going to be printed just as you see it there. Then we're going to have a variable, okay, and then separated by a comma. We're going to have another string, and then we're going to have another variable sum, and then and then the sum is going to be incremented, and then we're going to print it over again until, you know, since the print is in the loop, we're going to print the sum and the value of I every single time. That's the purpose of putting that print in that loop, so we can see what's happening. Okay, and then here at the end, we're going to say print. Now see, as I showed you, everything is working all right, but this is just showing you, this is just going to show you more of what's happening as the program is running. So the average equals that. Say average equals AVE, and I'm going to just copy this just for speed, and the sum here, the sum right before the average. Okay, then I'm going to compile that, save it first, save it again. That's what I just did. Save it. Now I'm going to compile it, and then I'm going to run it. ./a.out. Okay, so now you see what I was talking about before. I equals 1, sum equals 0. So this is the old value of the sum, and the loop evaluates I equals 1. It's not equal to 10, so it repeats again. So in the second time, I equals 2. The old value of sum is 1. Okay, so 2 is added to 1. Now the sum equals 3, and then it repeats again. Another thing what we can add to this is to show the old value of the sum and the new value of the sum. So one way we can do that is to say old sum equals sum, and new sum equals sum plus I. which is only evaluated here in the print statement. Okay, so sum doesn't get incremented twice. This is just computed here and printed here. The sum doesn't actually get incremented until this line. This is the line that increments the sum. So we're getting the old sum and the new sum on the same line. Okay, and you can ask me questions about this if you have any in class. So I'm going to save that, compile it again, run it a.out, and so now we have more. It's probably even clearer what's happening. I equals 1. The old sum is 0. The new sum is the old sum, which is 0, plus 1. So the new sum equals 1. Okay. In the second iteration, I equals 2. The old sum equals 1. The new sum equals the old sum plus I. So now it equals 3. Okay. In the third iteration, I equals 3. The old sum is 3. So 3 plus 3 is 6. So that's the new sum. It's always adding to the old sum, whatever you've accumulated in that sum. The new variable, that is what I'm saying, is that the new value of I is always added to the accumulated value of the sum. Okay, so here it's 3 plus 3 equals 6. 4 plus 6 equals 10, 5 plus 10 equals 15, 6 plus 15 equals 21, and so forth till you get to 10. So the sum of all of these numbers, this entire column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is 55. Okay? And then at the end we divide 55 by 10, which equals 5.5. Okay, so that's the third problem. And if you have any questions, please feel free to send me an email. All right. Hope that clears up everything. And so now you have everything you need to work on the homework assignment, which is going to be emailed to you. Okay.